Humans make up vast, economic, crazy, wild things that all these moving parts. But what if I told you even humans had crazy, wild, moving parts that make up themselves? Tens of millions of thousands of things make up your body. Just kidding, folks. It's in the hundred trillions. We're going to talk about microbiology today. And we even brought along a little guest.
That's me. I'm the little guest.
So I'm Dan.
Yeah. And I'm Nick, folks.
We're old friends dissecting one topic at a time.
But
People,
they can
technology,
hear us,
media,
so-
we've got it all covered.
You'll see.
Each discussion here is a deep dive into our unique perspective. Taboo, forbidden subjects, they're all on the chopping block, baby. We don't pander to popular opinion. We might even get a little bit dirty.
Warning, this podcast may contain mature language and sexual content, and is for infotainment purposes only.
So join us. Have a good time.
Open up your ear holes, because we're going to fondle your follicles. All right.
Whoa.
There we go.
That's wild. So there's two of us here, and look, we got a third person here.
Yes, we do.
Look at that.
We have a guest.
That's
a special
our guest. Oh my goodness.
Yeah.
That's Sue or SusannaLHarris. She's right now at the University of North Carolina. Could you tell us what's going on down there? Anything wild?
It's finally a little bit chilly. I'm originally from Iowa, so I'm watching friends on social media get snow and things like that. So
5
Other
inches
things?
and the world shut down, by the way, today. It took a lot of my friends like 3 hours to get home.
yeah,
No bueno.
nope,
Mm-mm.
nope.
Mm-mm.
So you're up in Philadelphia and you're in Houston.
Yep. So I saw snow the other day, actually, but it didn't do anything.
Whoa.
It was a flake.
Online or in person? Oh, okay.
I ran
I wasn't
around
sure.
gleefully outside for half a second.
You played in it, the snowflake?
Yeah,
That's
and
snowflake.
it'll return in another few years.
Did it look like a snowflake you've seen before?
No, I don't believe so. Because they're all unique, aren't they?
A unique snowflake. That's incredible.
Just like me.
Wow. Well, before Suzanne was rudely interrupted by my partner Dan, what would you say you do down there?
So I am working on a PhD in microbiology, and specifically, yeah.
What today? Go ahead. I'm sorry. Sorry. We're doing well microbiology today. This is a hell of a
What?
coincidence. Yes.
Wow. Yeah, I had no idea. And I specifically study how bacteria stick to plant roots. So that's what my thesis topic is in so many words.
That's pretty cool. I think that was going to come up today. So we're going to run with it. This is perfect.
Yeah.
This is awesome.
You've got like what, 1 year left? Almost?
Yeah, about a year left. Yeah.
So you-
Average is about 5.5 to 6 years, and so in about a year I'd be right at 5.5. So I think so. And then I have to figure out what I do with my real life.
Ooh, real life.
That's-
We're going to touch on
bummer.
that soon, I
Yeah.
think. Yeah, it is kind of a bummer.
So you're pretty much an expert.
Yeah, I'm just getting used to saying that, but I worked in a microbiology lab for 3 years in undergrad, and I've been in a microbiology lab for almost 5 years now here in North Carolina. So 8 years doing something, you should probably be okay.
Yeah, pretty good. Pretty good.
Pretty average. Pretty average.
Yeah, pretty average. That's what we're told mostly.
Okay.
It's like kind of disappointing.
No, that's cool. And listen, if I may ask, I was a bio major for like a year and a half, and I cut it because I figured there was a more lucrative career path with English journalism and being a newspaper writer one day. My parents, if you ever see this,
He laughed at you.
my God, my poor parents. Oh, she did. A lot of people have. Anyway, newspapers are not the future, but biology might be. I'm just saying, might be. In your field, like right now, doing your PhD and all that, is it split equally between men and women? Like, what's the kind of? Is it? You said it like that was like no.
Well, actually, it's really interesting because so my lab is mostly women. We have a couple guys. We're bringing on a postdoc who's a guy, but mostly women in my lab. And in the lower levels, it's becoming more and more women. There's like more than
Really?
50% women
Wow.
coming in as trainees.
Mhm.
The interesting thing is that there's still this huge shift in like the power structure, where once you actually get to the management roles, it's still really slanted towards white men. Yeah.
Yeah, of
So,
course. Well,
you know,
because no one wants to give up their jobs / power /
yeah,
whatever benefits you, right?
Mhm.
Yeah.
exactly. So it's kind of that weird thing where, depending on who you ask, some people will say, oh, it's getting pretty close to 50%. But if you look at who's running the show, still definitely slanted.
The money is still old white men.
Yes.
We're coming for you, unless it holds true when I get older and they throw it at me. I'm not a sexist. I'm just saying, could they please throw me some? I don't know.
Yeah, right.
Yeah.
Yeah. So, but good
That's
question.
interesting.
Mm.
I didn't know that. That's funny because also, like when people picture scientists a lot, they picture a guy in a white lab coat too.
Yeah.
You are more attractive than most guys in white lab coats.
I mean, it depends on your like persuasion, but like.
Yeah, you're absolutely right. I'm usually attracted to people who look more like Dan.
He would look great in a lab coat.
It's the dimple thing. It's right
Yeah.
here.
What is
That's
the
what gets me.
dimple?
Oh, that's my type, I guess.
Mm.
What are you gonna do?
I think the dimple looks better on dudes though, because like sometimes girls with the dimple.
Yeah, that's a good point. I know. Yeah, that's a true statement.
I
actually.
disagree.
Write it down. That's a
I
fact.
disagree.
When we find each other in the wild, it's amazing.
Oh, they fit perfectly. Oh my god.
It's like
So,
little
friend,
marble there.
they both have a marble that they push in between their chins. That's something they do. Yeah. So for everyone watching that doesn't know what biology is or microbiology is, or if I heard an echo, but that's probably someone else's fault. Anyway, so biology is the study of life, all the processes of life, right? So microbiology is what? The study of life that's, Wikipedia said,
Super
too small
small.
for microscopes.
Hmm.
It seemed like the worst definition ever. I was like, that's it? Like they were like, it's too small for microscopes. That's what we're going to call
What's your
it. And I
definition
was
of a
like,
microscope? Where did you get this definition? Is it Wikipedia?
so that's what it was on. And I thought that's a very weak Wikipedia definition. So I know you love talking about microscopes, Dan. Go ahead. Let us know what the first microscope was. Come on.
So it's not really the microscope that I'm interested in. It's the
Oh.
idea of small things, small living organisms. So initially they had this thing called Nagoda, which is like the Jainism. It's a religion. They had this idea that there were these small things everywhere and that they had like a really tiny life cycle and they were just like proliferating everywhere. So they had an idea of it. I don't know how. And then it kind of
Isn't this a little bit like Aristotle and Plato? One of them believed that things got infinitely smaller and the other believed that there was a stopping point, kind of.
I think it's almost like the recursion. Like Men in Black has like a marble universe. It's like as you get smaller, it starts to expand, and then you can't perceive that stuff. So I think the Jains were kind of into that sort of philosophy. And then I got around to a guy that made the first microscope using like glass beads, little spheres. He was actually trying to figure out the quality of a thread. I think his name was Antoine Van. I'm gonna say like just. Oh boy!
Off the top of your head. Go ahead.
Do you want some help?
Yeah, hit it.
Wait,
please say it.
Antoine van Leeuwenhoek.
Leeuwenhoek.
Damn,
I would have said it wrong.
And everything. That was pretty good.
Yeah, this is the start of microbiology. That's like, we all have to learn this part.
He was the father of microbiology. Mm-hmm. Like a whole sect of science. Big Daddy.
Daddy. That's awesome.
So yeah, he started looking at all different things and saw that, the thread was not really that interesting, and he started looking at the body. He looked at what like different blood and like just like things on your hands and like all the different organisms moving around. Plants, teeth, and then.
Do you think he had a girlfriend? He brought her over and said, "Girl, look at that body. Girl, look at that body." You think he did that? I had to. It was in my head. I couldn't let it. Sorry.
Yeah. And then.
I apologize. Anyway.
Yeah. And the next thing I was going to bring up was sperm, because obviously if a guy figures something out scientific, he's like, let's see what this is.
Look at his sperm?
Yeah.
He did?
Uh-huh. Which has the flagella, the little... whip on the end.
Flagellate?
Yeah.
Flagellate?
All of those are right by Susanna's standards. So, I mean, he looked at all that stuff and was like, wow, this is crazy. And I think he depicted it. He like put it in a book and said, hey, this is the stuff I found, and everyone's like, psh, that's bullshit. So that was 1620, I think, around that time.
Damn, I always thought you were going to say 1919 or something. That's way farther back than I thought.
No. And it took a while.
Yeah, go ahead.
It took a while until they got better and better microscopes. And I'm going to skip like all over the history and skip down to, let me see.
Looking at your notes.
Yeah, I am looking at my notes.
2003.
Yeah, 2018.
400 years, people weren't even making a better microscope. They were just, it's good.
So I think it was Carl Zeiss, and then this guy Ruska, which is newer. So he's like 1900s, and then Knoll. So they started making microscopes that worked off of different principles and different ways.
The early ones worked off light, right? Just reflecting light.
Yeah.
Right? Is that how it works?
Light.
Now, what's the next step up? Is there? I know they have electron microscopes. We're not getting to there yet, but what else can you do besides like just add mirrors?
Multiple optics, and then the way the optics focus, they're blurry. So they came up with something called I think this guy Abby came up with a sign condition, was a way of making it so the vision was not blurred.
Focused it?
Yeah, so he focused it, and then it skips.
So his name was Kodak. Wait, the guy who invented the camera? Sorry, I just tried to throw you.
So he skips. I'm gonna skip ahead to like electron microscope with Ruska and Knoll. So it's like,
how does an electron microscope work? I didn't look this up, but I'm smart enough. I could figure it out. Everyone listening at home, you could figure this out. Go ahead, take it.
I think it hits it with a stream of electrons, and an electron is smaller than the wavelength of light, so you can actually you can dial in on a smaller subject.
But it's not a visual. It's not actually giving you a visual. It's giving you a physical representation visually, like because it's not. You're not seeing the colors and everything. It's not really showing you. It's just bouncing off and giving you. I guess that's what light is. Never mind. Whatever. Sorry, guys.
No, it's fine. You got it totally right, though. It's like the easiest way to think about it is like
echolocation.
Kind of. Well, it'd be like if you were trying to figure out the shape of something, and light would be like throwing beach balls at it and trying to figure out where they bounce off, and you can find out what the shape is versus throwing ping pong balls. You get a much
more defined line.
I like that. That's good.
That's pretty cool. You should major in this, like in college.
For fun, yeah.
So electron microscope, like when they find like a new microscope. Yeah, you got your number?
Yeah.
Well, when they get a new one,
we've got one.
Are they like, well, let's look at everything again?
Rope it in here.
Holy shit, we just found 800 new things. Like, it's got to be an exciting time, right?
So this is literally what happened.
So what's the resolution? Give me it.
100,000 times smaller. So when you hit it with an electron, you can actually see that much more definition. And the guy Ruska,
100,000 times more than the last microscope?
Yes.
Or than the human eye? Yo.
Last microscope.
Okay. That's awesome. I was just checking. I don't know.
So this guy Ruska was really like, I don't know if they call him the father of microscopes, but he won a Nobel Prize for it. So he actually invented like the next series.
Nickname, but
he did like the next like 3 or 4 microscopes, and I think he made the most recent one, which is like the super resolution one, and he might have done the cryo-electron one too, which is less like a method of maybe not. Oh, she's heartburn.
No, that was those pictures are so good. They're so
really?
No, that was an excitement like.
Oh, okay.
Cryo,
that was a.
Yeah, it's beautiful.
Does it have the smoke coming off of it and just like liquid nitrogen wafting in the background? I feel like you're doing science that way. It's the only way to do science.
It really is.
Kind of is. We all agree to agree.
Yeah.
So, did you know I have actually a list of what's studied under microbiology? And I don't know if it's right, but this one was a little better than smaller than a microscope can say, which I thought was funny. It was bacteria, archaea, viruses, protozoa, microscopic fungi and yeast, and microscopic algae. And I was like, that's goodish. Is that like microbiology?
Yeah. I think the only other thing that would fall kind of under there is that some people lump in what's called immunology. So like, because immunology meaning
antivirus
systems, how your immune systems attack bacteria and viruses. That's one of those kind of weird ones where is that human biology, is that cell biology, is that microbiology? So it kind of just falls in the middle. Nobody likes immunology.
That will bring up an interesting point later about It's not called symbiosis anymore. Didn't they change the stupid name of it? Where cells work for each other and they aren't really related. Oh, endosymbiont.
Mm-hmm.
Is that like
See?
mitochondria help each other?
There you go. Oh, he jumped ahead, folks.
Sorry.
So I just want to dial it back in case anyone at home is like, I'm lost on this episode. Like, I hate these guys. They're talking way too smart for me. Let's dumb it down. Small things, folks. Microbes. You know what I'm saying? Small, little things. Look in the mirror, folks. That's you. You're this. So what we do is we study it, and there are a hell of a lot more microbes than us obes. You like that? I created that term. But you get the idea.
Should use that. Us obes.
Like I saw a TED talk, so you know it's true. But 10 trillion cells make up the human body, right? It's a good estimate. Right? Run with it, right?
I'll take it, yeah.
Do you know how many microbes live in your body? That's including bacteria, probably immunization little cells, all different sorts of stuff lives in your body. It's not just your cells. 100 trillion. You're literally made up of more not you than you. Depending on what you consider you and not you. But like this stuff exists all over the world. There's more bacteria than there is probably anything else. Is bacteria the number one?
Ooh, okay.
I think. Right. Oh, good. I'm ready.
I got this. I'm all over this, especially the thing you just said.
Okay,
so
cool.
The thing you just said was said like in every single microbiome talk. I know we're going to get into like what microbiomes are, but basically like that's how every single scientist would kick off like why people should give a shit about bacteria. Was that stat of like 10 to the X human cells versus 10 to the X plus 1 bacteria cells. And it turned out that this was some like weird science fact that came out of the back of an envelope. They went back and checked it and they found out it's not that far off. It's probably closer to like a 1-to-1. But what's really funny is they actually did the estimation and they were like, it's going to depend on when the last time you pooped. The majority of your bacteria are. And so they're like, that's going to depend on what you've been eating, if you've had antibiotics. But it is true. There's just an incredible number of bacteria. It's important to remember that like bacterial cells are way smaller than human cells. Right. So it's not like you're
1-to-1.
Right. Yeah, like some sort of horrible sludge monster, but
you might be listening at home, and we appreciate the listen. Just an FYI, what's going on for the regular folk,
for the normies. But the question of is like, are there more bacteria than anything? We think that the most abundant thing is either viruses or the viruses that attack bacteria. So
that makes sense.
Yeah, bacteriophages.
I didn't even get into this, but I read that one of the biggest wars of all time is bacteria versus viruses. And it had like scary music and a big build up and everything else. But like think of it, if there's more bacteria than anything else, and viruses like to infect things, and there's a shit ton of them, wouldn't there be more of them and more of them than anyone else that exists? Makes sense, right?
Yep. There you go.
I don't know anything about viruses. Is it viruses? Damn it! I overthought that one a little bit, folks. I really thought it was going to be one of those cool plurals. It wasn't. It's just viruses.
Viri. I like it.
We're going to run with it. I don't know much about a virus that attacks a bacteria. Is it essentially the same that would attack our cells, or is it's its own virus?
Yeah, it's totally its own virus. So that they're called bacteriophage, and they only attack viruses. It's similar to human viruses where there's specificity, like a virus that infects one bacteria won't infect another one, for a whole bunch of different reasons. But yeah, so we were talking about cryo-EM, like that's the kind of stuff where you can actually see bacteriophage like infecting bacteria, and it's mind-blowing. Just
friggin' sucking on the outside, shooting that DNA in there, RNA, excuse me, Jesus Christ, RNA in there. Am I right?
It depends. I think
some have different ones. Okay.
Yeah.
Okay. And then replicating and bursting out that cell. It's like pornography for germs. Okay,
And
folks.
scientists.
That's some rough pornography, but yeah.
Think of it. I mean, it's wild.
I'm
It's
not
exotic.
Sure what that would be, or if that would
Well,
be just like the full cycle, like you get to watch her be pregnant for 9 months.
I think that was the whole thing. That's like a whole pregnancy, getting pregnant,
Wow.
having the baby, just bursting, having so many babies burst. That's hot. So
I'm sure that's a thing.
yeah, I'm sure it is. If it isn't, it is at the end of this episode. Okay. So more bacteria, more of this. So really the study of this stuff is pretty damn important. I would say anyone who gets a degree in it is guaranteed 9 figures. Or it should be, in my honest opinion.
Including decimals.
Including decimals. That's not bad. I mean, that's not
I'd still take it.
Yeah, I would. So there was somewhere I was going to go. I was going to.
You want to talk about poop? I have my notes are all on poop.
That's awesome. Let's go.
So there's bacteriotherapy, which is intended to reintroduce bacteria into your body. Yeah, they're like probiotics, but for your gut, your colon, your rectum. Mm-hmm. So like one of the
sorry,
good hand motions. There's a hand motion.
I go a little far sometimes.
So it's interesting that the human body, it can be affected by things like C. diff, which is like a really crippling disease, or IBS, which is irritable bowel syndrome. Even like neuro diseases, like they have.
Real quick, what is IBS? Like, is it it's a disorder? So it's your body doesn't produce something at the right rate, or it has to crap too often? I mean, is that it's
I'll
not
take the crap too often.
Considered a disease?
What are my other options?
It's like a general inflammation. So like there's a bunch of stuff that links it to the microbiome, that like having IBS, having the symptoms of IBS, which is basically like your intestinal tract is really swollen, and it's like usually diarrhea and stuff like that. But yeah, it's just a mess. But it's linked to what's called dysbiosis. So a good microbiome, if it gets shifted off track, it's like it's occurred. A dysbiosis has occurred.
So these things, just to verify, aren't a virus or a bacteria infection. It's something entirely different. It's an unhealthy biome. Yeah. It's a bad biome.
Yeah. So the idea, like microbiome means like tiny biome, right? So you think about it like if a forest just dies, it's probably, unless there's a fire, that just ran through all of it, it's like it could have been anywhere in the food chain that things got messed up. So with IBS, it's like, well, was your body reacting, which threw off the bacteria, which threw off viruses, or like where in this chain did it happen? And that's really where a lot of this research is happening right now, where it's like, what is the interplay between human biology and bacteria if, like you said, human biology is bacteria at the same time?
Right.
Yeah, and the solution
go ahead with poop. Are you going back to poop here, Dan?
Yes, I am. So humans take the most inane route possible, and it's just like, let's stick things in there. One of the actual cures is that you take stool from a healthy person and do a fecal transplant into someone with IBS or another disease, and it works
because it reintroduces the microbes or systems from a healthy individual in their poop and brings it to you and says, hey, guys, hang out in here. How are we going to get there? Wait till you find out. The humans are the best. They're going to eat us? Nope. We're going in.
So that brings up, so that, like, the gut flora can actually affect your mental state. So it does affect different, I think it was like GABA. Do you know much about GABA? Do you want to talk about that?
Oh, no, go for it.
It's like,
God.
Do you want to just hit it? I can hit it.
Biochem I had to take 4 years ago.
So GABA is like an inhibitor. And they think people that are...
Is serotonin related? What does it inhibit?
Damn it.
It's
serotonin, isn't it?
I mean, there's a ton of stuff. So like the snare snap stuff, that's like neuronal processing. That's based on like electrochemical impulses. So like based on the term, there's going to be electricity, there's going to be chemistry, but basically it's the speed and the not resolution, but the sensitivity you have to those impulses. So yeah, there's been links between like mental and emotional balance and your gut health.
I've actually heard this, and the food you crave, more of the food you crave, obesity, some other stuff like that, right? Autism.
Mm-hmm. Yep.
I'm trying to think. There's a couple others I read, and I was like, that's pretty important.
There's some, well, I mean, there's all this like, so the lab I used to work in, they did a study where they showed that like antipsychotics that people with schizophrenia would take, there's one that was given to kids, which were really important, right? But kids were gaining like 30 pounds in the span of a couple months. And
That's a healthy boy. That's a healthy boy.
Yeah, going from 60 to 90, and he's like in fifth grade. But it had to do with microbiome shifts. They still don't know exactly what's happening there, but it's all connected. Nobody knows.
So what I gathered from what you're talking about and from what I studied for today was that I studied for today. No one knows how many months I prepped. Maybe I went to college, both of you, for a year and a half and studied this for this episode. So don't think I just looked everything up today, okay? But essentially, we treat diseases, we treat bacterial infections, and we try and find pharmaceuticals that cure these things. But there are certain disorders that hang around, like we mentioned, was it Crohn's?
Yep.
There's no way we can fight obesity, but are you saying they're finding new ways in the microbiome realm to kind of combat these things? So maybe it's not a bacteria thing, it's not a bacterial infection thing. It's not a disease. It's not a virus. It's something about how that gut flora makes us who we are. And there's a way to change that, maybe? Is that what you're saying? Is that what you're saying?
That's what we think. That's where the money's going. So that's what we're trying to convince people about.
Right.
Isn't it relatively unknown, too? Like, people haven't studied this. They don't really understand introducing certain aspects, like different bacteria, what it's going to change, how it's going to affect the ecosystem. It's kind of a crazy thing that it's like, how do you break that down into an experiment and do it on like a scale that affects everybody? Like, I don't know that you can tell. Like, probiotics, that's sort of a science, but I don't think they actually do what they say they're going to do. Oh.
Totally right. So a study came out 2 weeks ago. I mean, you said this was going to air in forever and a half, so it's probably like
200 weeks ago. Yeah, 200 weeks ago. That's incredible.
2 weeks ago from now.
In 2018.
Back in 2018. Remember that shit show of a year? So no, this study came out where they took people and they gave them antibiotics to wipe out their natural flora. And half of them, they gave probiotics, just the stuff you get off the counter, which, by the way, is usually just lactobacillus. Sometimes they say like 18 species of bacteria, and you're like, okay, these are all almost exactly the same thing. So they give them those, and then the other half, they didn't give anything, and they watched how fast those people got back to what was close to their baseline. And not surprisingly, the people who were taking a bunch of random bacteria that don't live in your gut, it took them a lot longer than the people who weren't taking probiotics to get back to their normal state. So it wasn't a question of like, if you're healthy, taking a probiotic is going to help, but that idea of you're taking antibiotics, so take a probiotic, it's something we've been saying is not true at all.
Here's a crazy question. So let's say right now we're running into the realm of interestingly enough, this field particular is almost pointing and saying getting antibiotics is bad. Which I don't disagree or agree with, but I tend to side on we shouldn't screw with our bodies. We're trying to make whatever. But let's find out we can introduce these microbes to people. We can do this to people. I can make you skinnier. I can give you this. What if there's a side effect for doing this as well? Again, we're screwing with genetics here. I imagine down the road we're going to find something that says maybe you shouldn't do that. A little Jurassic Park thing here. Life finds a way, or whatever you want to call it. Do we run into an ethics thing here, which probably isn't present in your field right now, right?
I mean, it's coming out. It's definitely a question. It goes back to that question of like, how far can we push ourselves past like what natural selection is, and the basic questions that people had, tens of years ago when they were like, should people be allowed to have glasses at certain ages?
Right.
Like, shouldn't you? And people say it with allergies too. I dated somebody for a long time, and you're much more sensitive to the kind of comments, but people will make comments that are like, well, if a peanut's going to kill you,
That's awesome. Terrible.
I know it's awful. It was bad, but it was sort of funny. He at least thought it was funny.
Good.
But yeah, I mean, we're gonna get to a point where we're only able to survive if we can do all of these weird manipulations, or at least that's the fear. So,
right.
Yeah, we don't know. It's pretty weird.
There's a weird balance where we fear the hell out of something like everyone's going to genetically modify their bodies to be skinny and beautiful, when in reality, it probably won't happen. There's a lot of things that step in the way. But if you could, is there a moral responsibility? Is there something there? I don't know, philosophical thing? Because anytime we try and change anything in nature, which is, by the way, our nature.
We try to game ourselves.
We try and game ourselves. There's always a blowback. There's always a hit back. There's always something that happens. So what I'm saying is, take your degree and throw it in the trash. We're not doing microbiology anymore. Okay? I'm gonna let this stuff live. Okay, but there was somewhere I was going. I really swear to God, guys. Oh, you guys know about cyanobacteria?
Oh yeah.
Is yours a cyanobacteria relative?
No, but like.
Let me go first. This is really important to me.
Do it.
In high school, I had to do a project on cyanobacteria, and it was like my big project for the year. Yeah, Gillespie. You know what I'm talking about, buddy. This guy over here. I researched the shit out of these guys. They're called blue-green algae. Are you going to tell us?
No.
Algae. Oh, okay. They're not algae. Don't make that mistake, folks. That's just their name, okay? Oh. They are the only prokaryote capable of making oxygen. Dan knows what I'm talking about. They make up how much?
I thought it was like 70% of the world's supply of oxygen.
I thought it was like 55, but somewhere in between that.
Someone's going to judge. There's.
She's like,
no, that's fine.
She's like, I'm not touching it.
I mean, to be honest, you could probably find both figures.
That's what I'm saying. Yeah,
absolutely. Just dying. But anyway, they made their all their photosynthesis happens in their thylakoid membrane, which is unlike I believe any other bacteria. I'm pushing the limits of my knowledge here.
Yeah.
But they think that somewhere way back, that they had the one of the original endosymbiotic relationships. You call it symbiotic if you're simple at home, but we call it endosymbiotic. I'm not sure why. I just know we've changed the term.
So what they were sharing? What were they sharing?
It's
Oxygen with something else.
Lives. Yeah, they were essentially making oxygen. It's like the beginnings of like how plants started making oxygen. They think possibly. No one knows for sure, but it's an organism that lives within the body or cells of another organism. I would say, with mutualistic relationships. Hell yeah. So say endosymbiotic, folks at home. Don't say symbiotic. You sound simple.
I mean, it depends. There are symbioses that are not endo.
Oh, I didn't get that far. Holy crap. Another country heard from. And what's the difference? I'm like trying to whisper so you tell me and not the audience. God, you can talk.
So endo just means inside of. So it's a symbiosis where one is inside of the other. But there's a whole bunch of different symbioses. There's
sea anemones, clownfish and sea anemones. Most sea anemones and clownfish, right? Cover most of the other symbiotic ones.
Those two things in repeat in different orders are every symbiosis.
Disney does a movie about Finding Nemo. That was a pretty good one, right? Mm-hmm. So we covered them all right there.
Yeah.
So I thought you could kind of segue here-ish to your favorite bacteria that hangs out in plant roots or something.
Yeah. So there's I think we're going to talk about nitrogen stuff later, but okay. So same way that we know that the bacteria and stuff that live in humans are really important, especially we've talked about the bacteria that live in the gut. And that's really important because it keeps us healthy. It helps us to digest food and take up nutrients. And the important things about plants are that they also actually have to take up nutrients. They make their own carbon or they fix their own carbon using photosynthesis, but they take up nutrients and they also can get diseases. They can also get infected by things. They have to fight off different stuff. One of the things that helps them is also bacteria, but they don't have a gut. They instead have roots. And so I study the bacteria on the plant roots, which really affects the health of the plant overall. So I don't know if I have a favorite. Well, I have a favorite bacteria, but I'm biased because it's like the main one that our lab studies. It's called Bacillus subtilis.
Okay.
And so everyone's heard of E. coli.
Yeah.
It's sort of like E. coli is friend. I don't know.
Cousin. We'll say cousin.
Well, so it's I'm immediately like, oh no, microbiology, they're not even like that related. So E. coli is the gram-negative model organism. There's like two classes of bacteria, gram-positive and gram-negative. And so E. coli is gram-negative. Everyone, if you're going to do gram-negative stuff, you start with E. coli because it's the easiest. If you're going to do gram-positive stuff, you start with Bacillus subtilis because it's like we know the most about it. So that's my favorite. Lives in the soil. It's everywhere. You could go out, like, doesn't matter where you are. You go outside, get some soil, you can probably find Bacillus subtilis or at least some bacillus in there. But it also sticks to plant roots and can help them to grow bigger. So.
Isn't it bizarre that you could find it anywhere? I mean, there's certain things like what, endoliths, and then see, there's another term, but they're like inside every rock. Like if you break open a rock anywhere on Earth, you're going to find these organisms living there. So they've been here longer than us, obviously, and then you literally can't escape them. Yeah,
it's pretty bizarre. I mean, there's tons of people doing stuff of like how often do these things travel around? Is it just that you have a population that is in one place, and they're actually traveling a lot? So, because they're going to be moved around by water, air, evaporation.
Is that thanks to us, or just naturally they would? Storms, water, all that stuff you said, but I feel like we move more of them now. Is that fair to say? Okay.
Definitely. We definitely move. We move them further, right? Because you're not going to really get a bacteria that's going to go from Europe to, the middle of Kansas. So, unless you have an airplane.
Okay. Well, we have airplanes now, by the way.
You have airplanes? Did you do that?
Yeah, we started
we
that.
Did it.
We don't have that in North Carolina yet. I mean, we invented them, but
wait a minute, Wright brothers. That's really funny. That's a good catch by you. Yeah. Kitty Hawk, North Carolina. If you guys are ever going, just check it out, man. The Wright brothers, great. Next segue. Sorry, go back to where we were.
So that's
like an advertisement.
Saving the planet, right?
I don't think we're good at advertising. We just did an ad. Sorry.
Yeah, Wright brothers. Boeing.
Yeah.
Well, we'll take all that.
Wright Brothers Museum, brought to you by the Unpanders. Coupon code UNPANDER. Get 5% off your ticket to check out the Wright Brothers Museum today.
And an extra for 10%.
By the way, don't do it for real because they didn't pay us anything. But if they do pay us, I'm just saying, 5% off would be pretty cool. What's 5% off $5?
Give you
25 cents. So you want to save the planet?
It is a quarter.
Yeah, it's a quarter. It's a quarter. But they're not going to give you a full 5% off. They'll give you the 1%. They'll just be like, here's your name.
Oh, okay. That makes sense.
You're right, though.
I apologize. Just showing our star power here, Dan.
Yeah, no, you got the math.
He's got it.
I don't do math. I do as like little math as I can.
So saving the planet. I guess that's your goal, right? For improving the yield on plants, making them grow faster, I assume, or better, or not perish, right?
Healthier.
Yeah. So, that's the idea, is that we can use these instead of using agrochemicals. So we can use them as kind of like beneficial agents in the field. And so one thing that's important to think about, we talked about antibiotics at the start, or in the middle somewhere, that it's important to remember that antibiotics are made by microbes almost across the board.
It's the battle of microbes, right?
Yeah. It's all these interactions. It's like this super fast, awesome signaling and warfare between them. And it's just that we realize, if we grow a ton of this and then take all that certain chemical, we can kill other microbes with it. So the idea is that instead of taking the microbe out of the soil, figuring out which chemical it is, and synthesizing a bunch of that chemical, maybe we could just take the microbes and put them back into the soil where we want them. And they can be their own little antibiotic factories. They can take care of the plant. We just put them in there. We don't worry about it.
More natural.
Yeah, more natural. So that's actually kind of true in some cases. But the problem is that this works, it's totally variable across different soils, different fields. It works really well in greenhouses, but not nearly as well outside. And we think that is because the bacteria that we want to grow with the plant is also interacting with the other bacteria that are living in the soil already. And so that's where my project comes in, is like, how does our good bacteria get along with other soil members?
So are you hoping it works for almost every plant, and how much better would it be? Like, how many plants would it save?
Well, I mean, the biggest loss of crop productivity is due to like blights and wilts fungus. And things like so. Fungus is one of the biggest reasons that we are not reaching food demands. You know,
we all saw
like bananas.
We get it. Okay.
Yeah, bananas are so sad. Coffee's having a rough time.
Is it?
Like, bananas grow out of a rhizome, so they're all interconnected, and once it gets fungus in there or blight, it kills like an entire segment of banana plants. It's essentially like culling swine, or like pigs, because they have swine flu.
Are bananas ripening faster nowadays? Is that a thing? I swear they are. We buy like 6 or 8 or whatever, and they're like 3 days later they're starting to be.
Do you think that's a
almost overripe?
Genetic
and
modification.
I know they release ethylene, and the more ethylene there is, they ripen faster. I'm not.
Yeah, don't collate your.
Don't science me, okay? Yeah, I'm just talking about the others.
Bananas.
Yes, I leave a banana at each corner of my house. One above the door for good luck, and one in the bedroom for good luck, and then one on each corner of my house. Okay, so.
In case you need some.
But they seem to ripen faster anyway. Never mind. I apologize.
So this
I really thought maybe there was something to it.
This kind of came up with.
It's probably just that, like, when you were a kid, your parents threw away the bananas that were ripe.
Like replace them with slightly less ripe bananas to make me think
they're always ripe.
Your bananas last forever, honey. Thanks, Mom and Dad. Thanks. Yay. That's possible.
It is.
Thanks, Mom and Dad. Shout out if you ever see this.
So this came up, not bananas, but like the root bacteria came up in our extinction one. Is like you said back in our previous episode, that was if we lost the bacteria that are exchanging nitrogen in our soil, then we essentially die. It also comes up for like the yields on plants, because the limit of the number of people on the planet is actually somewhere around like 10 billion, and we're at like 7.7 billion. Which is,
why do they say 10 billion? Because of the nitrogen content they need?
I don't know if it's the nitrogen content or like the arable earth, like the amount you could yield out of
physical space with resources included. I guess
probably water is probably a big issue too.
Yeah, well, water, whatever. I mean, we're not going to argue.
So that number, like 10 billion, we're going to hit 10 billion in about let me see, 30 years in 2050.
Yep, we are, folks. That's a smartwatch. Yeah. I still wear it.
So Susanna might actually be saving the planet by actually increasing yields.
6,000 steps. Sorry.
You're saving your planet. You're saving your microbiomes. Think of how many bacteria you're keeping there.
Are fit people better in their biomes? Just out of curiosity.
Kind of. There's a correlation between it's tricky because it seems to be more like diet related, and so you're going to have a more balanced like microbiome if you're eating a lot of fresh fruit and vegetables and lots of fiber and things like that. But like that's also people who work out and do like There's not like a lot of people who like run to McDonald's. So.
Right. What you're saying is 6-packs are made in the kitchen. You know what I'm saying? That's the old phrase in the gym. Come on, folks. You all know that. It's funny because I also wonder how much of these results that we see are the result of correlation versus causation. I mean, someone who is better fit, who leads a healthier lifestyle, would give off a different fecal microbiome than someone who isn't. Yeah. So are we seeing one versus the other sometimes? Is it hard to tell? I don't know. That's just something that came up when I was watching these things.
No, okay, so you talk about fecal transplants, and they've done stuff in mice, and they've done a little bit in people, but it's all weird.
Yeah. Do they use a Q-tip? Never mind. Go ahead. I apologize.
No, well, I mean, to put them into the mouse, I think it's usually a gavage, so it's like liquidy and just like it's just like a enema, but it's the opposite.
Wait, say that word again. What's it called? A gavage?
A gavage. Yeah, like a liquid. You syringe them.
Keyword gavage. There you go. No one's gonna search that one ever.
Reverse enema again, though. That should never be a thing. God. Okay. Anyway, yeah. So in mice, what's really cool is that you can take mice. This was one of the big, like, groundbreaking studies. You can take mice and you can feed them 2 different chows. You can feed them, it's the funniest labels for it. They can be like on the healthy chow, or they can be on the Western diet chow. So they can either get like lots of fiber and protein, or you can be like, you only get fat and carbs.
Big Mac.
So yeah, exactly. And not surprisingly, the mice that are eating the Western diet are getting really fat. But like, that's not surprising. What was really interesting is that they could take a new mouse and put it in there, and then they would take the fecal matter, they would take the poop from these different mice, and if they took a new mouse and gave it the healthy diet, it would be fine. But if they took a new mouse and gave it the poop from the mouse eating the Western diet, the poop was enough to cause that mouse to gain weight. So there was something about the microbiome shift.
So they ate the better food, but they still were gaining weight even with bad mouse poop.
Yep. Yeah. So if you took new mice and gave them the poop from the other mice, the ones who got the poop from the fat mouse also got fat.
Have you ever said poop and mouse that many times in a row?
I hope
not. Maybe on a date? I have no idea. I don't know.
Yeah. That's surprisingly, I don't normally bring up the like microbiology part that hard, because usually people are like, oh.
Not all well-versed individuals in the field, because it's mostly women now anyway. That's what I think.
I mean, that's fine too. But
so yes. What do you want to do? Do the nitrogen?
I was going to talk about. Can I ask you guys? This is a real question. So when I was getting back into bio, this past 4 months, getting ready, I came across that carbon is our building block. I know we're going to get too much into it and all this. My favorite thing is space. I love space. I just want to do a space aside here. In your professional opinion, could we have life on another planet that isn't carbon-based and doesn't use water? Water.
Yes.
Is it possible?
I think so.
The reason I ask you is because, if you want to get into, I don't know if you know anything about the archaea bacteria, but they're like the extremophiles. They like can feast on nitrogen and like ammonia. They eat weird things and they survive. But I feel like, is that an outlier? Could you make complex life from these systems?
I mean, there's like, so archaea are still carbon based. They sometimes get their energy from different things, but like still I think the majority of their mass is usually carbon. Okay. I don't know much about their.
That's how you know someone's like 100%
their
sure.
cell physiology. I know that they still are off the same, amino acids and the same DNA and things like that, which are a lot of carbon. It's more nitrogen, but versus some of the stuff that we're made out of. But they're still like fixing sugars and things like that. So, but archaea are super common. We just don't think about them because they don't cause disease, and so we don't study them. But they're all over the place, like literally all over the place. Highest mountains, deep sea, in the super thermal vents, like Yellowstone, those big vats of like acid that come out of the ground, which is horrifying. But there's archaea in there as well. But in terms of could there be life that's totally not carbon based? I think so. I think our definition of life would have to be different. Okay. And so, I mean, that's actually a big question of when you've got, the rovers going out and different people even just checking the chemical composition of things coming off of planets and things like that, we're saying, oh, we don't see carbon or we don't see water.
Right.
And we just might have too narrow of a definition of what life is, because currently we don't consider viruses alive.
Right.
So I think
it's possible. Methane based, and like, it also, if we go methane or nitrogen or whatever based life forms, we also change our scope of where we're looking, because it changes the temperature. I mean, a temperature gradient for nitrogen is different than going to be for carbon-based product. They don't need water, so now we're looking at a different range from the star. It all changes with that, and I think that's really cool. And I think I'm going to change my job and start studying extremophiles, because I want to find aliens. And if anyone's going to understand aliens, it's the people who understand how the weirdest bacteria we have evolve and live.
Mm-hmm. Mm-hmm.
Just real quick, the only caveat to what I just said is, are we assuming that life operates the same and evolves the same? And like, would evolution preclude no matter where life evolves? It has to, right? Or does it? We're getting deep as hell, and I had a couple drinks, but I'm just saying.
No, that's a good...
Rephrase that one.
All right. So what we understand when we watch bacteria, they change. They replicate, but different things evolve. They change. They can adapt to their surroundings. If we found life on another planet entirely different than our version of life, would it too have to adapt? Would it too have to change? Or is there such a thing as life on Neptune, or some planet that looks like Neptune that's nitrogen based or ammonia based, but it's life that isn't anything like we've seen, and it doesn't change? Is that possible? It's just the same.
Like the root could be the same, but it's going to adapt and change based on where it is because of its environment.
No. What if it didn't?
I mean,
what
I think
Darwinism didn't.
Right.
Yeah, I get. So is that not life then?
No.
Damn. Shut down. You don't adapt and change, you're done.
I mean, I like where you're going with the idea of like, is there life that does not adhere to natural selection?
Yeah.
Because that's been a big question of, that was actually a big question, like, I don't know, 25 years ago in microbiology, is whether or not microbes followed the same rules as bigger organisms in terms of natural selection, because they don't have to mate. They don't, they can change their DNA very quickly, and they can actually change their DNA in response to something. So it was this idea of like, Darwin had the idea of, okay,
natural selection.
Yeah, natural selection, versus Lamarck had the idea that, you know, giraffes had their long neck because the ones who stretched out their neck had more babies, and then those were able to stretch their neck longer. And Darwin was like, no, the ones who already had longer necks, we kept those. And there were some really cool papers that looked into that. So as far as we can tell, bacteria also follow natural selection. I think the same rules are applying to archaea, but I mean, I don't know. I think viruses still would technically fall in there, just in terms of the mutation occurs before they're chosen. But yeah, that's one of the biggest tenets of life, is that they have to adapt. They have to reproduce.
Okay.
So what about like bacteria that are resistant to certain antibiotics?
How do they change? Is it just random also?
Yeah. So it's just it's errors. So every time a cell, like, there's a certain replication error rate.
Okay.
And so bacteria have like 4,000 genes. It totally depends on the bacteria, but E. coli, right, it's going to have like 4,000 genes. And so every time E. coli replicates, it's going to have like 10 to 20 errors just that happen. And most of the time that's going to happen in somewhere that doesn't matter. It just doesn't, who cares? There's so many bases, but it could happen somewhere that changes something. It could change the amount of a certain protein that's made. And if that happens to be beneficial in that specific environment, that bacteria and its progeny are going to do better than its neighbors. And so very quickly, your population is going to be totally taken over. And all of a sudden, where you used to have one like code for all of your bacteria, you're going to have two, and eventually you're only going to have one again, but it's going to be a new code. And so your life that's living in your microbiome, in that case of that bacteria, is going to be different. And so that's why bacteria are, that's why I think they're so cool to study. They're super fast. And that is why, you know, there's this kind of arms race between humans and bacteria, that like what we can do, what we can change, like you're saying, like gaming your life, we're just like barely keeping up with bacteria, and not very well.
So let's lean on like superbugs. Do you think what we're doing with like antibiotics and like cattle, we pump antibiotics into our food because we want it to survive? Isn't that a terrible practice? Like, won't that lead to like the most damaging superbug ever? I mean, that seems like that's a dumb idea. not to charge it in any way.
How do you feel? Yeah. No, there's a bunch of new stuff that's coming out that's like just when we're using a ton of antibiotics, it's just not good. Like my personal opinion is that we should use antibiotics as the last option. I mean, they're great. We should definitely have them. I don't agree with people who say like, just never use them. If you're going to die, you're going to die. I'm like, no, we don't need like 5-year-olds dying of strep throat. That's like just silly. But we also
Stachybacteria. What was that? Sorry, I was naming the strep throat virus, but then bacteria, and then I forgot it, so I trailed off.
Halfway through, too many syllables.
You both stopped, and you were like, "What was it?" And I was like, "Oh, I started saying it to be smart, and then I forgot it." Stachyo.
It's streptococcus, but I can't remember.
Oh yeah, right, streptococcus. Whoa, never mind.
Yeah. Anyway,
Dan, where's your damn silent key? Never mind.
Dan, I can't say it. I can't
surmise.
Streptococcus pneumoniae. Is that the one?
Okay, it is pneumonia.
Okay.
Yeah, it's streptococcus pneumoniae. So I was wondering, but it's also the one that causes strep pneumonia.
It has a variety of them though. Yeah, there's the pneumococcal ones too.
Pneumococcal. There you go. That's my boy. God damn it! Why did I do that? No, I derailed it.
You blanked on it.
I did it. I did it.
I got you. Yeah. Are antibiotics good or bad? I don't think we should use them to make our chickens bigger. What's funny is that it's not only... Yeah. I mean, to be fair, if we could do that for people, like everyone would be just taking antibiotics all the time, myself included. But like...
As a biologist, real quick, because I have a lot of customers, people I see every day who are like, yeah, the antibiotics in our chicken or make our daughter's breasts bigger. And I'm like, I think that's true, but I don't have the science behind it. It's bullshit, right?
Well, I'm just like horrified at where your customers are. I'm like so glad I don't work with people.
Humans are terrible, by the way.
Yeah, no. Absolutely.
I know you're trying to save them, but they're awful.
No, I mean, but no. So there could be something. There could totally be something because
it could change your hormones, I guess.
Oh yeah. Well, the thing is that we use antibiotics. We use these crazy high antibiotics in feeding our livestock. But it's actually, if you look at it, some of it started out because they were like, we've got bacterial infections running through because we've got all these animals like crammed together in a box. But when they're free range, giving them a bunch of antibiotics makes them bigger. That's one of the things that feeds this idea that it could be a shift in the microbiome that's causing them to get bigger.
Is that an obesity type thing?
Kind of.
Maybe.
Yeah. Okay. Yeah. They have found that people are, if you take antibiotics, if your microbiome is screwed up, you're a little bit more likely to gain weight. So, but yeah, something weird is happening. So I don't know if it actually.
So my customers are right. God damn it.
Well, I mean, unless they're eating the chicken like
nonstop, like it's like four meals a day. Yeah, that's most of their daughters. Yeah, from birth, four full chickens a day. And he's like, look what they're doing to their breasts. And I'm like, sir, I can't look. I will go to jail again. I will just believe you and take your word for it.
Don't look at your 8-year-old daughters.
Yeah, right.
Yeah, I can't.
So
that's a bit outside my range.
To shift a little bit,
derail the conversation. Yeah. I'm really sorry. Go ahead.
So I guess the area I want to go into is like scientific ignorance. Is that the general population doesn't really know any of this? Like I would say it's probably like 90% of people have no clue what's going on whatsoever, and I think it's getting worse.
She's excited. Oh my God, she's about to go off.
Take it. Go ahead and take it.
Go off.
All right. Yeah, because like what I really want to get into is science communication, and what you're talking about is really interesting because it's what a lot of scientists go off of, is this, it's called the deficit model of education. So it's this idea that the majority of your population don't know what you're going to tell them. And it actually turns out that if you go off that model, it's really hard to get through to people, because it's not that they don't have information, they have the wrong information. So like most of the outreach now is focused on avoiding that deficit model and going more towards like this misinformation model. So the majority of people know something, but it's the wrong thing.
Horribly wrong.
Just horribly wrong. Yeah. And so if you come in and you're like, you don't know anything, they're like, oh, but I do. So you have to come and be like, what do you know? And they'll tell you stuff. And you're like, how do you know that? And they're like, does that make sense? And eventually get in there. But yeah, the idea of like scientific illiteracy, and I think that that is the biggest thing, is that, you know, a lot of the things that people think that don't make sense, you could those people could figure it out if they were given the tools to like feel comfortable using logic. I think our school systems really scare people from thinking too hard, because if you're wrong, it's a problem. And the thing with logic is you have to hit like every single wrong answer before you get to the right one. And so, yeah, a lot of people are really good at just like picking up information and being comfortable with it because it's much better than not having the answer. But that's where you get these answers where you're like, that doesn't even make sense.
Yeah, it's being afraid of failure. Like if you're going to actually build and design something, you're going to fail a whole bunch before you get to the final solution. And that's acceptable. And most people are probably not comfortable with failing that much and actually succeeding in the finished product.
Yeah, no, definitely not. So, yeah, so you brought up science literacy. Yeah.
No, sorry. Like people come in and they're like, granite is stain proof, and I'm like, it's not stain proof. And then I'm like, quartz, it's made of metal, and I'm like, well, there's no metal in quartz, man. Let me break it down for you. And then they're like, can I have granite? And I'm like, it's you're thinking of marble. What you're talking about right there is marble. Anyway, I just wanted to let you know, misinformation is the #1 problem in our industry. People come in, they think they know everything, and yet they don't. And this applies to science in some ways.
So scientists are also probably not the best communicators. I took that up.
Good.
They also, yeah. So I've dealt with a lot of scientists, and they never summarize things in a way that people can digest. It's always, here's a lot of data, and they're not going to pick things out and say, this is what I think, because that's kind of against what they're told to do. They're just supposed to present the data and then
collect data.
Yeah. Unless there's like a very definitive route, they're not going to tell you that it's one way or the other.
Yeah, that's a real thing. that's for sure an issue. I mean, even when I've been talking, you've noticed I'm like, oh, there's a study, and you're like, who gives a shit? Like, it doesn't mean anything if I say there's a study. It just I could just say this is what we know. Yeah, I think it's a mark of a good scientist to be able to back up their facts. And when I give a lecture to my lab group, that's what they're asking for. They don't care about what my opinion is, even though whatever I'm telling them is my opinion. I haven't read every single piece of literature. But in terms of that idea of summarizing, the way I usually tell people, because I do get to train, so part of my outreach is I train other scientists to communicate their science. And it's really interesting. I do it through the local planetarium, Moorhead Planetarium. It's where the Apollo astronauts trained. Fun things.
Cool.
But usually the analogy I go with is like, if you went into your auto mechanic, I don't know anything about cars, and so it's a terrible analogy for me. But like, if I go in and I'm like, there's something happening, I think it's the transmission, because my friend told me it's probably a transmission, but I think it's a transmission, and they check it out. I want them to be able to speak to my level. I don't want them to do the scientific thing of sit me down and try to explain what combustion is and give me the entire history of automobiles. But I also don't want them to talk to me like I'm a dumbass. I don't want them to be like, so your car goes vroom because you put in the spicy liquid. And you're like,
spicy liquid? I never heard that. There's a first, everyone. On pander, just quote that spicy liquid.
The spicy liquid. So I think that's what scientists need to do better, is realize that they don't have to pick one extreme. They don't have to teach somebody every single thing that there is to know about their topic to get across the right level of information. But really what scientists need to do better is ask what someone's background is. You know, my auto mechanic should say, you know, like, how much do you know about cars? Or they should be like, so drivetrain. And if I'm like, I have never driven a train, they should know to lower it back down. Scientists should be able to say, like, hey, you know, like when I say cell, what do you think of? And if somebody, like, I work with 5th graders and they're like, red blood cells are dead because their nuclei has gone. And you're like, okay.
Oh,
damn, yo.
Damn, yo, hey.
Go off, kid.
Yeah. So you can never assess it, but like that's what scientists need to get way better at, just asking, well, what do you know about this thing? And then talking at that level.
This is a huge problem in the medical field as well. Doctors and like whoever, when they go to tell you a diagnosis or explain something to someone or parents of a child that needs a surgery, there's no go-between. There's no, well, he has a sarcoma, blah, 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 and a femoral artery number 7, blah, 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 and then you have some that are like, he got boo-boo, we gonna cut him open. And you're like, let's find somewhere in between. Like, come on. We can all talk like adults here. I don't know. So I think any specialized industry runs into this problem. And not to undercut the whole conversation, but the whole problem is capitalism. If you can make more money making someone feel stupid, people probably will do it. If you can make more money keeping your secrets hidden, you will probably do it. If you can make more money, this sentence seems to come up a lot, but it is what it is. I mean, money's super important.
Yeah. Well, even with your job, I mean, I'm sure that sometimes you get people in there that know exactly what they're doing and you're not going to try to like bullshit them. But if somebody comes in, they're like, I really want this thing. And you're like, whatever, I'm going to give you the most expensive thing because I hate you.
I hate you. You're a jerk. Right.
Yeah.
Right.
No,
it's all about communication. It's a language you use. And that happens on all levels and all jobs and all places. So.
Well, how do you two, like, it seems you come from different backgrounds, sort of, like you do different things now.
We went to high school together.
Okay. So at least you have like some of the same vernacular of like what, you know, humor and stuff like that. But
someone body checked me into a locker and then I hated him for a little while and then we're best friends.
Like a week.
Love story.
Yeah. Our meet cute. This is our meet cute.
Hi.
You know.
So I guess the part I wanted to weigh on is that I think Susanna is like an outlier. Like a person like you does not exist normally in nature. So
are you an outlier? Would you say?
Do you think you're an outlier?
Yeah. It's kind of funny because
Except that you
I really like people, and I'm like, I think everybody in science used to be a nerd. Like everybody, well, like we still are, and it's really awesome because
different now. It's different now, but I'm not going to get into that.
Yeah, but but we were all the kid who got like pushed into a locker, so like I at least have that in common with everyone. But no, it is. It's weird, and it's also something that's not been valued in science. It's getting better now, but it used to be like it was just seen as a huge waste of time to try to communicate to the public. It was like, why bother with that? They're not going to care. They're not going to understand. Get back in the lab. And so it's just now at a point where it's getting valued. And I think that I am an outlier right now, but I do think that that's going to be changing. I hope. My God, I hope.
So I guess my question to you is, why do you think you are the way you are? Why do you think you're social, you well-spoken, have salient points? Yeah. It's all microbes.
It's flora.
Nothing else. And then you're also going for your PhD, which is extremely rare.
Yeah. I think a lot of it is just privilege, to be honest. I think, I grew up in Iowa in a very safe suburb. My parents both went to college. My dad
white or black?
What?
White or black?
I don't know. I've never met. No, my dad. He used to be a salesperson, but then when I was in middle school, he became a high school biology teacher, and so he was. Even when he wasn't that, he was always really excited about science. And so I had this like huge dual opportunity where I was in a really supportive environment. My parents really got me engaged in the sciences in school. I was like horribly socially awkward. And so I like read books constantly, which turns out to be nice as an adult.
Useful, yeah.
And yeah, I was just like really encouraged to always ask questions. So I think that that's a really big piece of it. As far as being well spoken, that's actually because of the social anxiety. It used to be a really big problem, and so I had to go to a bunch of different classes and actually like pushed it way far the other way. So that's why I'm a scientist, but I also don't mind public speaking. It doesn't freak me out.
Interesting. Sounds like someone else on this podcast.
Yeah. Well,
not me.
Surprisingly, when we've done this podcast, I found out that Nick is actually shyer than I ever thought. He's more afraid of the things that took me a while to come around. So there's an element of me that has become more socially aware and more outgoing through this process. And I'm curious, like, what pushed you to get more socially out there? Because you have a lot of information about you out there through Instagram and Twitter, and she's freaking out. And also, like, the talks that you've given, like, they're out there too. So there's like probably like 4 or 5 videos of you talking about whatever subject.
Oh yeah, a whole bunch of stuff.
Can I interject? I saw a video and I was like, oh, let's see what she talks like. I didn't know if you had an accent. I didn't know anything. And it was like a video where you were injecting a serum to excite a bacteria. And I was like, let's see what's going on. And that was it. It was like 30 seconds long.
Oh my God.
That's the first one.
I was like, that was it?
That was the iceberg.
She didn't even say anything. I was
tipping
like,
point.
I don't even know.
No, that was like literally I had to make a YouTube channel for some
this was like holder. It was a holder.
Oh, it wasn't that old. It was just like I had to do it for
holder, like something to hold the.
Oh, holder. I was like, holder.
No, I'm not. I didn't assume you're older back then. I know how time works. Usually.
We'll do a quick jump back. Yeah, no, I didn't do anything with that. So because of the outreach stuff I do, I thought about getting involved in science outreach online kind of by myself. And I mean, as you two have probably figured out, there's just like a lot of work that goes into doing every little piece.
Yes.
Yeah.
Yeah. I mean, you have been actually, like, you've both done your research on this topic. So that's, or at least you can fake it really well.
Oh, yes. PhD bullshitters. Thank you.
Yeah. So, no, but like, that's the thing is I started, you see this stuff online, you're like, whatever. They just pop on, they talk about some stuff and they're done. And it's way more work. So that's why I started doing more collaborative stuff. So I find other people who want to chat with me, or who like the video editing, or they like other parts. I really like Instagram. It's a really easy medium for me. So it was something that I was doing anyway. There's some pretty basic rules of like what is going to get looked at, what's going to get engagement. And it's also a hell of a lot safer than Twitter. Twitter is going to be why I get fired. I don't know why exactly, but it's like.
You can actually state an opinion.
Same.
Yeah.
You know.
I hope my employers don't find this.
Yeah, people are super, super nice. I'm more open online than I am in actual like human version.
But they're also
human version.
Meaner. Like it's safer to show your range, would you say, online, I guess? Because like you're sort of anonymous, not condemned. Anonymity, and you're.
You can never say that word.
They live together. I don't know. He doesn't sting him with his tentacles. It's perfect. He lost his son.
Yeah, you can't.
I don't have those videos yet, but when the PhD stops getting funded. But so yes, I think you can kind of choose which piece of yourself you want to put out at a time, right? Where
I hate that she's doing this because like
the range of
I was going to follow her on Twitter, but I feel like my Twitter is like really depressing or dark or mean or whatever. But that's where I vent a lot. So I'm
get that anger out.
But anyway, you can decide to be whoever you want to be. Some of us are a little rougher around the edges than others.
Yeah, I always wanted to make like a fake Twitter account. I don't have one. I've always wanted to make one.
A burner account?
Yeah. But I'm like, I have like 5. I will for sure mix it up though. I will totally like be on my regular.
Drop your address and the name of someone you know and be like, I hope this person gets shot by a bow and arrow. And then in parentheses, not killed, just shot. And you're like,
lightly grazed.
Like
take that, pal.
Or something.
A flesh wound, you know?
Yeah. No, I mean, I don't know. The most annoying part to me about being recognized in some avenues like that. Like it's so useful in a lot of ways that I've gotten a lot of opportunities from doing this stuff that I never would have before. But my biggest annoyance is that now when someone's a jerk online, I can't just be like, well, I hope you go die. I'm like,
go F yourself.
You can't say that because it's a little, I get you.
Yeah, I have to be like a mental health champion. But yeah.
Speaking of mental health, do you want to touch on anything mental healthy?
Do you have any tattoos?
Before we wrap up?
Do you have any tattoos? Yeah.
Hey, I got a tattoo. So. Wait, what do you have? It better not be the one I was thinking of. Okay, cool.
So there's a little sun, but I don't know if you can see it.
And it's a sun.
Move over.
Oh, what's I just saw the white part.
Inside.
Another sunrise. Another sunrise.
That's a good move.
There you go.
Well, I never saw yellow, huh?
Yeah, so it's white and yeah. It's if I get tanner, it like ends up being a little bit different.
The Playboy bunny next to it.
So I don't know. Did you see the Monty video then?
I did.
Oh, well,
I don't know what you're all talking about.
Well, that's a.
It's weird, isn't it? When someone says they've watched your video and they talk about it, you're like, I don't remember that at all.
I mean, pretty much. Like I got off that stage and I was like, oh shit,
that was good.
What just happened?
It was good.
How many people are you doing it in front of?
What?
How many people did you do it in front of? I'm serious.
It was about 350.
Good Lord, I'm a little afraid of public speaking, but I do a podcast that the world could see. But anyway,
it's different though, right?
If you're live,
different. Oh, it's because they're live. It's like weird.
They're right in front of you, coughing and sneezing and ignoring you.
Yeah,
I feel like the cutoffs are like 2 people, 6 people, 12 people, 80 people, 180 people, over 300, and then from there, there's probably like a 8,000, and then I don't know. But
you get like Madison Square Garden level.
Yeah.
Human cares.
Right.
Yeah. Yeah, so that was probably that was pretty intimidating. But what was actually scarier is that I knew that they were going to be videotaping it, and
oh yeah, that'll mess with you
forever.
It will,
forever thing.
Right? And so,
would you touch your hair like this? Would you go like this with your hair?
Yeah, no, I so there were 2 really scary parts of that. One was like knowing that was going to be videotaped, and so it was like, oh, this is like, even if I bomb in front of these people, like there's going to be record of this. But the other weirder part was the coming off the stage. So that, oh my God, my dogs are just like sneezing everywhere. They're my whole life. They're the best. So there's a local storytelling group. It's called the Monty, and Jeff Polish runs it. He has a PhD in biochemistry, but he just does like storytelling and all this like really cool different stuff. So you can get a PhD and then you not use it at all. And
there's no money there anyway. I get you.
There's really not. So he helps people take their real life stories and turn them into some like spoken story, and it's 12 minutes long, and you're not allowed to have any props or any notes or anything like that. And the story that I ended up going with was it was really terrifying too, because I had started this thing that's called the pH depression, and it started on Instagram as just a way to show an image, right? Instagram, you just see these pictures and you're like, oh my God, they're happy, and you click on it and it's always a story of like, I went to the beach and it was amazing. Yeah. And I wanted to highlight this idea that, especially in academia, we show a really like pleasant, happy face, and there's a lot of this really like ugly darkness in there. And a paper came out earlier this year that showed that about 40% of graduate students are currently dealing with either anxiety or depression. And like, that's pretty high. Like the average adult population is more like 6 to 10. So, but 40%, super high. The thing is that I deal with depression and I felt super alone. I had a really hard time a couple years ago. And so I started this group, the pH Depression, on Instagram. It's since grown, and that's really where the social media thing has been coming from. But, I knew this person at the Monty, Jeff Polish, and he was like, hey, if anyone in your group would ever want to give a talk. And I had told people that I had depression before, or like through this social media thing, and some people who knew me knew about it, but I hadn't really ever told them the full story of why it all came out. And so the story I told the Monty was basically that it was about 2.5 years ago now. I was having a hard time a little bit anyway, but I failed this really important exam, and it totally threw me for a loop, and it just sort of doubled down on this imposter syndrome of like, I don't know what I'm doing. I shouldn't be here. I suck. And really ended up in a really dark place. And the Monty video it ended up with me talking about how, I don't know how much like y'all talk about on this podcast, but
what topic are you thinking? Like depression?
Oh, I mean, yeah, depression.
We did an episode on depression.
Yeah.
Oh yeah.
I love it. I mean, I don't.
Yeah, we love it too. We love it. Yeah.
No, so I got to the point where I was just in a really bad spot, and I ended up going and getting a permit for a handgun. But one of my rules was before I actually could buy the gun, I would get a tattoo, because it's something I just would never ever do.
The handgun
would stop you from the other.
Yeah. So I got the permit, but I was like, I cannot actually go buy anything until I get a tattoo. And I got this tattoo, which is what he's referencing.
And that was when you were younger, right? You were like high school?
Yeah. Well, so the idea for the tattoo came through college. It came from some stupid reference online, but it was like I had a rough time in college, and the takeaway is like I had mental health issues all the way through. It's just like it kept popping up. And so in college, I had this phrase that was another sunrise, another new beginning. But it was the idea of like, okay, tomorrow will be better. But it was also that idea of this darkness will be gone eventually. And so it's a reminder to like, okay, wait until the next sunrise. And so what I ended up getting was this tattoo where the sun is pretty obvious. If you get anywhere close to me, you can see this little black sun. Cool. You see that I have a tattoo, but it's actually, I have to let you in. Really, I have to show you, the real meaning behind the tattoo and what it means. Yeah. So I got this tattoo, and I had to wait until it healed so I could see it. And by that point, I had come through closer to the other side of that period of depression. And so I spent about another year kind of just dealing with it. And it was after that year that this paper came out. And I was like, I wish that I knew this was so common last year. And so that's why I started the pH depression, is like, I wish that the pH depression had existed a year before when I really needed it. So it's been cool. The response has been amazing. There's a bunch of bummed out people out there. So it's nice.
It's cool. Do you own 5 handguns by now, or?
Yeah.
Yeah, different days. I just keep tattoos and handguns. No, I don't. Never got the handgun, because I don't think I've had it for very long. But yeah. So it's been interesting. What did you all talk about on your depression episode? I mean, I'll just go watch it. But.
Yeah, we won't get too crazy, but I'm dealing with depression right now. We're not going to get into it real big because it's me, and I'm one of the members of the episode, and we haven't really discussed my personal life 100% because it's still ongoing. But anyway, I just thought up a new tattoo a week ago. I want you guys to see it. I haven't gotten it. It's supposed to say 10 to the 80th H. Do you know what that is?
Is that like
10 to the 80th power hydrogen?
Is that the sun?
No, it's not. It's 10 to the 80th power hydrogen. They surmise that based on the current rate of expansion in the universe and all the stuff that's going on in it, that the observable universe and everything we know is made up of 10 to the 80th molecules of hydrogen. Oh. And no one else I know has this tattoo. And it makes me think of the universe.
Yeah.
Literally, the entire universe is so huge. It's literally a number we can't even surmise.
It's on your forearm.
But if I could put it on my forearm, it's almost like all the drama we have, all the crazy stuff I have, all the times I might think really dark thoughts, or be so overwhelmed I can't breathe, or you feel like you're drowning, or you just want to sleep forever, or you just want to eat everything, or you just want to drink.
Yep.
You could look at your forearm and say, hey, look, it's only 10 to the 80th hydrogen.
Yeah.
Which is a lot of hydrogen. Don't break it down, folks. 10 to the 80th is a huge number. But anyway, I'm thinking of getting it. I haven't decided fully yet, but it's funny you said that. I just thought this up the other night. And I'm dealing much better But I think that's a really cool website. And when this podcast is over, I will check that out.
Yeah, it's going pretty well. So
Good.
yeah, you can check it out on Instagram. It's like, and Twitter. It's at ph_d_epression. That's what happens when you've got like a microbiologist doing branding.
_epression. That's cool.
But
check it out.
Yeah, it's going pretty well, and I hope you get the tattoo because it's been helpful to me, because I think that was what was really the acceptance part for me, was like, this isn't ever really going to be over. Like, there's going to be, it's not just like being like, hey, there's a dark period, let's like look towards the light. It's like, okay, there's probably gonna be another dark period. Like, let's
it'll come back.
Yeah,
it's cool to have other people in a connection. Yeah, I like that. Just to end it, I don't want to end on that. I know that sounds weird or bad, and I don't think that's bad or anything. I just want to ask a like philosophical biological question. Like, we see countries. Australia said this to Asia. Jesus Christ, I almost said Asia. Australia said this to China. United States did this with Canada, whatever. We see all these countries, and they always act the same. But when we break it down, there's all these people in these countries, and there's a lot going on. It's a political climate, and I'm not trying to get political, but our bodies are political, right? We got bacteria in here, we got cells, we got hormones running through us, and all this stuff is going on inside of us and making us act a certain way. Mm-hmm. Is it weird to think, out of the philosopher Alan Watts, we take credit for our own actions, but we blame things when they happen inside of us? I have a fever. I'm sick. I have Crohn's disease. I don't think Alan Watts ever said I have Crohn's disease. But for the record, we take credit when we do something good or we accomplish something. But we blame stuff that happens inside us we have no control over when it's the other way around. Well, what are we? Are we this combination of bacteria, cells, microbes, all stuff going on? Or are we this brain that makes it all do something? Because I really don't know.
Well, what do you think?
I don't know, because then I just said, like, China said this to America, said this to Canada. And we look at those and we're like, that's not it. It's deeper. There's more than just Canada said this to the United States the other day. It's microbes inside and the crazy complex relationships they all have. To make a sports metaphor, is it really just team A versus team B, or is it preparation versus coaching versus player skill versus development versus assistance coach versus positional coach versus who was sick that day versus all this stuff? And you can pull your hair out going crazy trying to gamble on these games. Don't gamble, folks. But really, it almost always ends up being more complex than we could ever imagine and more simple than we can ever imagine.
Yeah, I both of those analogies I think are great. You know, in the country analogy, it's like, who has more power, the thousands of people or the single government head? You know, like, is it your brain or is it all the rest of it? And then with sports, it's the same thing, right? Like, you always look at who did or didn't get the final catch, the final touchdown, the final shot. But there's the full game before that if anything had changed, you wouldn't have that exact same trajectory. So I don't know. I think it's weird. I think it's cool. I think that the way that you approach that question tells you if you like science. If you're like, that's weird and I want to think about it, you might be a scientist.
If they're willing to pay for my PhD, folks, I'm talking to you there or wherever you are.
Always an angle.
I'm interested. Just saying.
Do it. Do it.
So if we were doing a recap, guys, all we talked about the whole episode was cyanobacteria, right?
Every time, all of it.
Blue-green algae.
Those,
not really an algae.
Yeah, red tide, dino, what is it? Dinoflagellates?
Dinotopia?
Someone's favorite. That's what it is. Flagellates.
Damn.
Almost got it. Next time.
Did you see that on my Instagram?
I did. I was weirded out for a time. Really weird. Until I found out it was red tide. I was like, oh, that's nothing. That's no biggie.
Yeah.
Talked about
rhizobia. I love them. Nitrogen-fixing bacteria in legume root nodules.
Yeah, we covered that one. We also covered the crop rotation with the corn and soy, I believe.
nitrogen cycle. We talked about it endlessly.
Haber-Bosch.
Oh, did we talk?
Yeah,
Krebs
we covered
cycle?
that.
We did Krebs
2%
cycle,
of the world's energy.
Krebs
We
cycle.
cover all that.
We
We did
talked
cycle.
Yeah.
We did
Cyanamide, I think that was the one.
Menstrual cycle. We did every cycle. We were spin cycle. We were permanent press.
Fluff and dry.
Fluff and dry. Talked about the sexual nature of fluff and dry.
10 billion. A lot of us.
Industry. 10 trillion. Wow.
2050.
So.
Microscopes. Is that it? We covered everything?
Yeah, I think it's everything.
We might have done
incredible.
It. Yeah.
Wow.
Microbiology.
Well, folks, here I am before you, and I want to say we like you. We like you a lot. Thanks for donating thousands of dollars to our Patreon. Keep it up. And in the meantime, if you want to check out Susanna's page, you have a page.
It is down below. It says.
Oh, cool.
Yeah, it's in the
down
video.
Sure.
It's about.me/SusannaLHarris or phdepression.com.
Cool. And if you want to check out our website,
you can do that too. It's
you can do that too.
Right there.
Am I pointing the right way? I hope I am.
You're close. That's enough. They'll figure it out.
Thanks, folks. Thanks for joining us tonight.
Yeah.
Have a good one, and
Good night.
don't let those microbes get you down.